Nearly, I had 10 years of teaching experience and 6 years of research experience. So today we see about the artificial intelligence in electric vehicle. So, so the vehicle technology brings convenience in traffic for humans, but causes serious global warming and air pollution and depletion of oil resources and other issues. So therefore, the hybrid and pure electrical vehicle is the most effective way to reduce the emission of carbon dioxide, which is almost about 45% of internal combustion and engine vehicle emissions, or even a non-exhaust emissions. So electric vehicle system will become the effective solution to reduce the air pollution and fossil fuel. So the use of this electric vehicle has been largely promoted. So for this development, we have increased the challenges in the power system in the context of planning and operation due to the massive amount of recharge needed for the electric vehicle. So further, also the electrical vehicle may also offer new opportunities and can be used to support the grid to provide the auxiliary services. So this electrical vehicle have become an important component due to the advantages presented when compared to the internal combustion engines, that is reduction of noise and decrease in the greenhouse gases. So over the last few years, this electrical transport has been largely promoted by the governments as an effort to reduce the dependence on fossil fuels and air pollution from vehicles propelled by the internal combustion engine. So the massive introduction of this electric vehicles in the power distribution network leads to the adverse effect in falling some quantities. So voltage drop or increment in the energy losses and overload on grid components and power quality issues and reliability indices. So thus we go for this artificial intelligence. Um, Artificial intelligence plays vital role in this. Artificial intelligence is currently used to optimize the batteries which is used to power electric vehicles. When it comes to battery optimization, the main goal is to create the safer batteries that recharge faster and last longer, and also more sustainable than the present lithium-ion batteries. So what are the algorithms supported in this electric vehicle means normally the AI is defined as an algorithm which has a natural thinking and perception and has been a industrial and academic applications in the field of electric vehicles and its such as EV battery design, charging stations, and even a small grid also. So depending on the problem, this AI algorithm can have a classic rule-based system, which is also called as expert system, which uses the human knowledge to define the rules within the system due to their ability to define unusual trends and simplify the implementation. So in today's session, we have seen what are the recent AI techniques in some researchers have proposed some recent AI techniques in the electric field. So let's see. In this first paper, this AI-enabled blockchain-based electric vehicle integration system for the power management and smart grid platform. So in this paper, so the researcher proposed the AI technique. So this the system is based on the artificial neural network, and they are using the proposed technique they are using is a federated learning, FEL. So federated technology. So this federated learning approach for EV charge prediction, in which this EV fleet is employed as a consumer and a supplier for electrical energy with the VPP platform. So what is this VPP means? This virtual power plant. This virtual power plant is the network of distributed power generating units and this flexible power consumers and storage systems. So this VPP balance the load on the grid by allocating the power generated by the different linked units during the peak time, peak load. So this VPP has been proposed to act as an intermediary between the distributed energy resources and the power control loads and the electric vehicles. So this paper, they are using the neural network based EV charge prediction for the power management in virtual power plant. So here they are using this learning processes of federated learning technology, that is FL. So this FL will enforce the raw data production and improves the efficiency. So this method, this proposed method produces a very reliable and timely services to supply the electricity from the EV electrical vehicle network. And when here they are comparing with the conventional technique also, so which gives a very reliable and improve the efficiency. So next is, in this paper they are using home electric vehicle charging scheduling using ML technique. So here they are using the SVM technique, that is support vector machine. So with the help of AI and advanced metering infrastructure, that is AMI, which is used for the analysis of the electrical vehicle integration, which plays a very vital role in the future smart grid. So because getting data from the smart appliances and processing that data using this advanced techniques, which is to get the desired output, is a real-time challenging. So here they are using the machine learning technique called support vector machine. So this support vector machine, which is used to analyze the home charge scheduling. With the help of this user energy consumption, this electric vehicle state of charge SOC information at different levels can be monitored, and it can be predict the status of the electric vehicle. So this an active machine learning algorithm, that is a support vector machine, is successfully applied for this scheduling the electric vehicle. So depending upon the type of the data and the length of the data, we can you can choose the machine learning algorithms. So there is the machine learning algorithm is like a deep neural network, regression, logic regression, or SVM. We can choose this for and for electrical vehicle charge scheduling. And this application of this AI technique to public EV charging station analysis and the commercial electric vehicle optimal placement are also proposed as the charge scheduling. So in this paper, they are using this support vector machine, and previously they are using this neural network based FL method, that is FL technology is proposed for this charging methods. Next, third is energy management of hybrid vehicle using artificial intelligence. So here their main aim is to improve the energy efficiency of fuel cell based hybrid electric vehicles. So improving the performance of the fuel reduction and feasibility of the optimization, the efficiency. Here they are using the fuzzy logic controller. So this fuzzy logic controller FLC can be utilized by utilized for the control and the management of hybrid electric vehicle.
இது எப்படி எடிட் பண்றது? வேற ஆப்ஷன் ஏதாவது இருக்கா?
Participants, please mute your mic.
ஜியோடைல் எடுத்த டேட்டா வச்சு எடுத்துட்டு மறுபடியும் அதை எடுத்து போடணுமா?
Participants, please mute your mic. So here they are using the fuzzy logic controller. So this fuzzy logic controller is used to improve the power control and management of hybrid electric vehicle. So this here the state of charge is a famous criteria to tackle this fuzzy logic control technique. So with increasing damage from greenhouse effect and the fuel crisis and poor air quality, this emergency of hybrid electric vehicle has become one of the most popular for fuel efficient and for clean vehicles. So So fuzzy logic means fuzzy logic was first introduced by Lofty in 1965. It has been applied to many fields. Uh, it mainly depends on it uses the membership function to design the fuzzy sets. Each set has its own physical meaning, and based on the membership function, the data inputs can be assigned in different fuzzy sets. Sorry. So this proposed optimization technique achieves the high reduction in the fuel consumption in hybrid electric vehicle when compared to the other conventional, that is traditional algorithms. So once again, I repeat this. First paper, they are using this federated learning technology, that is neural network based FL method. And second, they are using this SVM, support vector machine, for the electric vehicle charge scheduling. Participants, please mute your mic. Uma Maheshwari. Participant Uma Maheshwari, please mute your mic. So in third paper, they are using the fuzzy logic FL technology for the energy management in hybrid electric vehicle. Next, fourth is in this paper, they are using the deep learning method to predict the electric vehicle power requirements and optimizing the power distribution. So the automotive industry is moving towards a more cleaner energy source, and the usage of this electric vehicle is increasing. So one of the major problem in electric vehicles driving range covered with fully charged battery. So here they are using the recurrent neural network. Modular recurrent neural network technique is used to predict the power requirements in the electric vehicle from different data inside the vehicle network. So the proposed method uses a different data and parameter from the electrical vehicle, like power requirement to the electric motors under different conditions, and power requirements of the electric vehicle are used to model the system within the recurrent network to train the network to predict the power requirement. So by predicting this power demand of the electric vehicle, the battery power distribution to the motor can be more optimized, as instead of delivering the power. So as such, it can be controlled based on the classification of power demand. So with this modular recurrent neural network deep learning algorithm is applied to the electric vehicle for the power prediction. So it is observed that the system is optimized and the power requirement of the electric vehicle is used to enhance the driving range. So with this MRNN method has a system adapt to changing the input data, and it gives the more accuracy with the less error rate. So when it is compared to the traditional technique, this recurrent neural network gives very more accuracy and also with the less error rate. So this MRNN algorithm smoothens the prediction of the power demand. So if any one of you have an idea in this means, they also give a future, the extension is, here they are considering only the inclination in which the vehicle is moving the battery power, and so you can add two more parameters also, that is battery degradation and drain characteristics, which is not considered in this paper. So you can use this, you can additionally add these two parameters in this recurrent neural network also. The last is artificial intelligence based state of charge estimation of lithium ion batteries for EV applications. So here they are using the battery technologies are almost the most trending research in the automotive sectors, which as a result in these uh, electric vehicles. So the existing methods in state of charge is estimation of lithium-ion batteries used in electric vehicles, which can explore a many AI technique-based and direct measurement techniques. So here they give the state of charge estimation, which using the Coulomb counting approach and SVM methods. So and also they are using the optimal feed forward artificial neural network is proposed to estimate the SOC, that is state of charge, with using the lithium ion batteries in the electric vehicles. So this AI technique, here they are using two techniques. So one is for a linear data, that is battery exhibits the non-linear characteristics, which focused by the ANN by using the artificial neural network, and another one is by SVM model for the accurate SOC estimation. So this SOC is a measure of usable energy in the battery, and this accurate SOC estimation has been an underlying challenge in all the battery-based applications. So this battery and the energy storage system is it gives a very different electrochemical and thermal mechanical conditions. So this SOC of the battery is a very subtle descriptor, which is not easily measurable like other descriptors such as voltage and current. So the accurate SOC estimation enables BMS to improve the system reliability, integrity, accuracy. It has been observed that this multi-layered based this artificial neural network model can be used for accurate runtime state of charge estimation for the lithium batteries. So this method does not depend on the battery physics as well as the ANN. This is purely based on the data-driven approach. So this network can be applied to different battery variants. So here they are not considering the this work. They have mentioned that this we can add a few more parameters for this using this technique, that is SVM. They are using this. The work can be further extended to collect the battery data for the different drive cycles, considering the real-time scenarios like temperature sensing and the SOC predictions. So just summarize this 5 papers. The first paper is used by this AI based. They are using this FL approach for this electrical vehicle integration in peak load demand. And the second one, they are using the SVM technique for electric vehicle charge scheduling. And third, they are using the FLC physiology controller in energy management in hybrid vehicles. And fourth, they are using recurrent neural network to predict the electrical vehicle power demand requirements. And fifth, they are using SVM technique for the state of charge estimation. So with the shorter running time, I just want to conclude this. So most of the approaches discussed in this or optimal electrical vehicle location and energy management. So this AI is currently used to optimize the batteries which is used to power electric vehicles. When it's come to battery optimization, the main goal is to create the safer batteries that will recharge faster and last longer and more sustainable than the present lithium-ion batteries. So this AI will add more value to the cars, helping the accelerate the production and maximize the production capacity. And we can gather the data with the unique user experience. This AI is everywhere. Just I thank all the participants. So I am the coordinator of this FDP session. 5 days we are successfully completed. I will share the feedback link in our WhatsApp group. You can fill this feedback Google form link, and we sort out the shortlist this attendance list. Near 80% attendance is must to get the certificate. So once within 1 hour, I'll share the feedback link in our the WhatsApp group. So once again, I thank all the participants who all attend this 5 days of FDP in recent times in electric vehicles. Thanks to all the participants. So any queries, you can contact me in the WhatsApp group. One small request. Please don't send any personal messages to the WhatsApp group. This group created only for the official purpose. Hope you all understand. So I shared the feedback link in our WhatsApp group. Thank you. Thanks to all the participants. Thank you.